Okay, Algebra 2 students, I appreciate you finding time to get your notes taken care of. This is the third lesson in the logarithmic unit, and today we're going to begin to take a look at the function itself. So please copy the title, the logarithmic function, as well as the objective. And our objective for today is to acquire basic properties of the logarithmic function. So we spent a couple of days looking at the mathematics dealing with logarithms. And of course, as you probably suspect by now, the logarithmic properties have a function that go along with them. That function is a graph, and that graph comes with its properties as well. And of course, we've also looked at the logarithmic function a little bit earlier this year, but now we're going to see all of the different properties that it has to go with it. Okay, now flashing back just a little bit, we've spent the last few weeks studying the exponential function. Well, this is a particular representation of the one of the parent functions, kind of the most basic parent function, dealing with the exponential. Okay, so we've been looking at y equals 2 to the x, and as we have studied over the last few weeks, the exponential function, the parent function 2 to the x, is mostly horizontal, going to the left of the y-axis, mostly vertical, going to the right of the y-axis. It crosses the y-axis at 0, 1, and that's pretty much been the function that we've started with. Okay. Now, one of the things that we have also discussed is the topic of an inverse function. And as you hopefully have noticed, we've talked about the inverse function. We've kind of refreshed our memories on it several times throughout the year because they continue to grill us on tests. They keep asking about the inverses. So hopefully you should be well aware by now. An inverse reverses the x and the y variables. Okay. Now, what that basically means to a graph is we end up with a resulting reflection going through the line y equals x, which makes perfect sense because if we are reversing x and y in the equation, we are basically establishing that the x value and the y value are equal to each other and they can be changed for each other within the equation. Okay, so there is y equals x in the graph along with our basic parent function y equals 2 to the x. Okay, you can just add that line into the graph that you already have. You don't have to draw a new graph or anything like that. Okay, now if we reflect through the line y equals x, like we were just talking about, we end up with this new blue line, which is the equation y equals log of base 2 of the argument x. So log base 2 of x. Okay, you can add that line, that graph, or that curve into your graph that you already have going on as well. Be sure to label all of these different equations. Some of y'all have taken to doing cutting as many corners as you possibly can in your notes, and the result of that means you have a bunch of notes that are basically useless because when you look back at them, nothing means anything because you've skipped so much stuff. All right, so as we have previously established, and now you're going to write down again, the exponential function and the logarithmic function are inverses of each other. Now that should have been clear to us back a few units ago. We were doing some solving in some equations, and we learned that in order to cancel out something that was exponential in the problem, we could use the log in order to do that. And if to cancel out logs, we could use exponentials. And as we've seen in the last couple of days, exponential function and logarithmic function, they are alternate versions of being able to write down the same equation. So our parent logarithmic function that we're going to kind of base everything on is going to be y equals log base b of x. Now b is a variable. We're going to be assigning this base value some values. So it won't just be log base b of x. B is going to actually be a number. Okay, so here in a moment we're going to look at what restrictions b must have on it in order to be the parent logarithmic function. Okay, now as we just said, b is still a constant, just like it has been in the problems that we've been working here recently. B is some number. Typically we operate in base 10, but it could be anything, okay, when the parent function is involved, as long as it meets a couple of requirements. So once again, just like with the exponential function, b is going to have to be a positive value. Okay, so it's going to have to be greater than 0. And b is not going to be allowed to be 0 itself. I'm sorry, make a correction on that. The b value must be positive, and it is not allowed to be a 1. That's the same restrictions that we saw with the exponential function. Okay, and since the exponential function and the logarithmic functions are inverses of each other, they're going to share the same restrictions. Okay. Now, once again, with so many potential values of the base, we're going to be seeing a whole bunch of different possibilities of the parent function. Okay, so we may see a little compressing and stretching of the parent function. Okay, but as before, if it starts to reverse directions or upside down or things like that, then something has definitely changed it from being the parent function into something else. So it could be compressed or stretched, okay, in different ways and still be the parent function. Okay, so our basic properties here is our parent logarithmic function is going to come up along the negative y-axis inside of quadrant 4. It's going to pass through 1, 0 on the positive x-axis, and then it's going to turn outward towards infinity in quadrant 1. So that's very much the same behavior that we saw with the exponential function, but it is of course inversed, so we are moving kind of from different directions. Okay, now similar information, domain and range. It's going to be the same idea, okay, but domain and range is going to be reversed for the logarithmic function. This time our domain is the one that is limited by the nature of the graph, so our domain is going to go from 0 to infinity. 0 is not going to be included as part of the graph, and another way, of course, of writing that is that x is going to be all of the positive real numbers, or x such that x is greater than 0, and it will be our range this time that is going to be all inclusive. So our range is going to go from negative infinity to positive infinity, or just simply stated, all real numbers. Okay, so our logarithmic function is going to come with an asymptote. Okay, but again, since we're looking at the inverse of the exponential had a horizontal asymptote. The logarithmic has a vertical asymptote. Okay, and in its parent function, or parent positioning, it is that asymptote is passing through the origin, just like it was with the exponential. Okay, so our asymptote is basically positioned there. Its equation is x equals, okay, any vertical line has an equation that says x equals, and then where does it cross the x-axis? Well, in this case, it's crossing at 0, so our equation is x equals 0. When it comes time to graph, we're going to be employing some of the same graphing strategies. We will try to understand which side of the graph is mostly vertical, which side of the graph is mostly horizontal, and we will pick step sizes that are appropriate going each of those two directions from our intersection with the x-axis. And that's kind of where we're at. One side is more horizontal. On that direction, we're not really concerned with a lot of height change, so we're going to take bigger steps. And on the other side, we are very concerned about the graph being more vertical, so we will take smaller steps to make sure we get the curve and all that of the graph right. Okay, so that's pretty much the basics of the logarithmic function. A lot of this should sound very familiar with the way these graphs have been going and the way we've been progressing with our different functions. So I appreciate you getting the time to take the notes today, and hopefully, gladly, these weren't too terribly long. So I'll see you in class.